Hey, what's up? This is Randy. Today we're going to learn the properties of logarithms, which will feel a little bit like the properties of exponents. So today's rules are the product rule, the quotient rule, and the power rule. Here we go. So let's start with the product rule. It states that if we have log base something of the product of two numbers, we can actually separate that into two separate logs with that same base. So again, you can see that we have b, b, and b, right? The base does not change, but instead of having m times n, we can now have the first log with m and the second log with n, all right? So let's do an example of this. All right, rewrite the following expression in the form log of c, which is like this form that we started with. So basically, we need to go from this form into this form. All right, so if we have 5 and 12 separate here, what do we do to make it look like the form log of c? As usual, try each of these by yourself, and then we'll do it together. So what do we do to m and n in order to get mn? We multiply them, right? So we just need to do 5 times 12 when we write the form log of c. All right, there it is. 5 times 12 is 60, so let's write log of 60. All right, so there it is. Our answer is log of 60, so we're finished with that question. But you probably noticed that right here, we have no base visible. Same thing right here. And even in our answer, we have no base visible, right? What does that mean? Well, this is another example of an implied value. It's called the common logarithm. So if we have log of 5, that's the same as saying log base 10 of 5. And over here, we have log base 10 of 12. And we have over here log base 10 of 60. And there's even a log base 10 right here. So log base 10 is the common logarithm. But because it's implied, we don't actually need to write all those 10s. All right, so you could describe this as log of 60, or you could even say, if you want, log base 10 of 60, and that's also correct. All right, beautiful. Now let's talk about the quotient rule. The quotient rule states that if we have log base something of the quotient of two numbers, we can rewrite that as two separate logs with the numerator right here and the denominator right here in the second log. And we have subtraction this time. All right, pretty straightforward. So let's try to do an example like this. So log of 42, or log base 10 of 42, minus log of 7, or log base 10 of 7. What's that going to give us? That's going to give us a 42 in the numerator and a 7 in the denominator. So log of 42 over 7, but we can simplify this to be log of, what is 42 divided by 7? 6. Log of 6. All right, so just like our value for c in this first example was 60, you can see that 60 corresponds to c. In the second example, our value for c is 6. But the entire answer is log of 6. All right, now let's talk about the third rule for today. This is the power rule. So if we have log base something of a number to a power, this power, you can see, can actually move in front of the entire expression and become a factor that we multiply the rest of the expression by. Now, it's very important to realize that although they're not visible, there actually are, in a sense, parentheses in front of the log and after the m. That is to say that this p is being multiplied by the entire expression inside the parentheses. All right, so in our example, we start with the form like this, and we need to write it in the form of log of c. So how do we convert 3 times log of 4 into this form right here? Well, just like this p goes into the exponent on m, in order to look like this original expression, this 3 needs to go into the exponent on 4. So we're going to have 4 to the power of 3. All right, beautiful. Log of 4 to the power of 3, what is 4 to the power of 3? Well, that's 4 times 4 times 4. In other words, 64. So this will give us log of 64. So 64 is our value for C, but the entire answer is still log of 64. All right, now that we have reviewed the product rule, the quotient rule, and the power rule, we are finished. See you next time.